All right, suppose you want to find the sum of the numbers 1 through 10. So that is, 1 plus 2 plus 3, 4, 5, 6, 7, 8, 9, and 10. Now you could just add this directly, like 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, and so on. But I'll show you another trick, this is one that will work for any set of numbers, for any set of sequence like this. Let's rewrite this in reverse order. Okay. And then add these column-wise. So 1 plus 10 is 11, 2 plus 9 is 11, 3 plus 8 is 11, 4 plus 7 is 11, and basically every column comes out to be 11. So what we have here, you count, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 of these 11s. So this is really the same thing as 11 times 10, which is 110. However, notice that I wrote this sequence twice, so this is actually double the value of the sum of the numbers 1 through 10. So what I'll do next is divide by 2, and that gives us the answer 55. So what I'm saying is that the sum of the first 10 is basically 11 times 10 over 2. And that can be extended to more general cases. So if I want to find the sum of the first 1,000 numbers or the first 550 numbers, I can make use of this technique. But there is a simpler formula that's based on that technique. So the sum of the first n terms of an arithmetic sequence is given by this sum here, the n times a1 plus an over 2. So where a1 is the first term, an is the last term of the sequence, n is the number of terms in the sequence, and then divide by 2. So for instance, in terms of the last one, my a1 was 1, my a10 was 10, and there were 10 numbers. So S10 would be 10 times 1 plus 10 over 2, and that comes out to be 10 times 11 over 2, which is the 55. All right, let's try this one. Let's find the sum of the first 40 terms of this sequence. So arithmetic sequence. So 4, then 10, then 16. So I know that the D is going to be 6 because I'm adding 6 each time. And my starting number is 4. So I know D is a 6. I know A1 is 4. Now I got to figure out A40. So let's first think of the general term A sub n is the first number, A1 plus n minus 1 times D. So it's going to be 4 plus n minus 1 times 6. So A40 is going to be 4 plus 40 minus 1 times 6, which, let's just put it in the calculator. That'll be 4 plus 39 times 6. Try it again. Order of operations. So that's going to be, I guess, try this. 4 plus, let's see here. I don't see any parentheses. Oh. Let's see. 40 minus 1 times 6. So I end up with 238. Okay, so 238. All right, so that comes out, the first 40 terms then is S40, which is going to be the 40 terms, and then my A1 is 4, my A40 is 238, then divide by 2. So that 4 is that one, and then the 238 is the next one. and then the 40 there. So this is essentially 40 times, and parentheses 4 plus 238, and then divide by 2, and we get 4,840. So for one more example, try the same thing here. Find the sum of the first 50 terms of this arithmetic sequence. So you know that A1 is 3, and then my D is from 3, I would add 5 to get to 8, add 5 to get to 13. So my A sub n is going to be 3 plus n minus 1 times 5. So my A50 would be 3 plus 49 times 5, which is 248. You can work that out. And so the first 50 terms is going to be the 50 times 3 plus 248 divided by 2. And I'll go ahead and let you put in the calculator, but you get something like 6,275. So you add up the first 50 terms of this sequence, it comes out to be 6,275.